And there's a few problems left we need to do from the outline. I did take the test. Well, I made the test and then I took the test. And there's 10 problems. I think that the level and time, you should have plenty of time to do it. A few of the problems will only take at most a minute, but then some might take 5 minutes. But for 10 problems, 5 minutes each, that's your 50-minute test. But some of them will not take very long at all, and others might take a little bit more. Any questions? Okay. We are on number 18. There's definitely one similar to this. Consider a freshwater aquarium with a stock of 45 gallons and a recirculating pump flow 150 gallons per hour. Calculate the residence time of the water in the tank and explain the meaning of that. Remember, residence time, that's how long each of those water molecules stay in the tank, since this one's water. Our stock is the water, and we're going to find out how long it's in the tank before it goes through the pump and is cleaned or oxygen. And that's what you're looking for then. Residence time is how long it sits in there before it goes through the pump. So for this one, you want to remember that residence time is your level of stock divided by the flow through the system, or the flow rate. Our level of stock, it said, was 45 gallons. And the flow rate was gallons per hour, and it was 150. The gallons will cancel and it'll leave per hour. So if we take 45 divided by 150, you should get 0.3. So it takes 3/10 of an hour. Let's change it to minutes, because this is kind of small. Maybe a half hour we'd be able to visualize, but 0.3 hours. We could go 1 unit smaller to minutes. We know 1 hour is 60 minutes. And I put hour on the bottom so they would cancel. So it's 18 minutes. The water that's in there is circulated 18 minutes it takes. Any questions on that? So if you dumped water into the tank, it takes 18 minutes before the water you just put in circulates. Any questions? Definitely. Number 19, an estimated 300,000 deer are harvested in Pennsylvania each year by hunters, and another 100,000 are killed in collisions with vehicles and other means. If the average lifespan of a deer in Pennsylvania is 4 years, estimate the total deer in the population. That's using this formula again. because they're telling us how long the deer live in their group. That's your residence time. The flow rate is the amount that are dying. So we would add those together. So using the same formula, the residence time, a deer lives for 4 years in this Pennsylvania section. And we want to know the population. That's the level of your stock. And then the flow rate can be the flow coming in or the flow coming out, because remember, we want to keep them in an equilibrium. It would be now you could just put 400,000 there. I just wanted to show you where it's coming. Excuse me, sorry. I just wanted to show you where it's coming from. So I added them together. Remember, your total population is the total number of deer. And you could leave total population. I just wanted you to visualize what it was. Okay, if we want to solve for the total number of deer, how do I get rid of this 400,000? What do I have to do to it? Think of the
Multiply it to the other side.
exactly. You want to think of the opposite. Since you're dividing, you need to multiply. That way it multiplies to the other side. 4 times 4, 16 and 5 zeros. So there's 1.6 million deer. Oh, another thing on the test, I put to write all answers in complete sentences. So make sure when you get your final answer, you put it in a complete sentence. The number of deer in Pennsylvania is around 1.6 million. Or there is approximately 1.6 million. Or you can leave it written like this. Any questions on that? Number 20. Estimate the annual cost of energy for an electric clothes dryer. I think we did one like this. I can't remember if it's the same one, but it was a good problem. And I'm pretty sure that one's, I was almost took it off, but I'm pretty sure it's still on the test. Maybe I'm not sure. I'm not seeing it, but study it just in case. And it's good proportions. I tried to put a lot of proportions on the practice, so then estimate the annual cost of energy for an electric clothes dryer. The dryer consumes 3.4 kilowatt hours and runs 5 hours a week. So it's 3.4 kilowatts per hour. And we know 5 hours 1 week. 5 hours per week. I left hours on top so the hours would cancel. We know the cost is 13 cents per kilowatt hour. Now, we wanted annual, so if you want to make week, year first, you could, or you can get rid of the kilowatts and get the money in there. It doesn't matter which one you do first. Since week is right here, we know there's 52 weeks in 1 year. My weeks canceled, my hours canceled. I have kilowatt hours per year. I want to find out money per year. I know 13 cents per kilowatt. So 1 kilowatt is 13 cents. Now, if you want, you could change that to dollars here, or you could change it at the end. Just remember, when you get your answer at the end, that's in cents, not dollars, or make it dollars right here. It's up to you. So if you just put 13 here, when you are done, you need to convert it to dollars because it's going to be more than just change. Any questions? Okay, I'm gonna put something on. Should be getting around $114. It was $114.92. So the electric clothes dryer costs approximately $115 per year. Now it's up to you. You can leave it in cents. You can round it to dollars. If I didn't specify, it's up to you. Any questions on that? Okay. Number 21 is definitely on there. And what I did was I gave you an incandescent light bulb and an LED, and I wanted you to see the difference. Now the one on the test will be a different watts. So if we look at the incandescent, it says find the efficiency using these 2 light bulbs. Notice the LED actual, I let you know that it's actually using 2.5, but it's a comparable to a 25. So you want to be careful of that. But it's 2.5 watts for the LED. And then you use your lumens. Efficiency is the useful power output and get the word they used. Oh, just power input. The useful power, that's your lumens. And the output is your watts. So if we look at the incandescent first, it's going to be the lumens are 220. Right? Make sure that's what. Yeah. It's 220. Whoops, I moved it too far, sorry. But you're getting the lumens, which are right here. Sorry, this one's kind of blurry. But the lumens on this one is 220. Now, if it's blurry on the test, let me know. Maybe I'll go in and write. What they are, just in case you can't see them. So this one, the lumens are 220 and our watts are 25. Now to convert this, because we don't want lumens per watts. If you look on your formula sheet, it's right here, 1 watt is 683 lumens. Because efficiency should not have units. 1 watt is 683 lumens. Now, these can be written as a rate, which is the decimal. It can be written as a fraction or a percent. I like to use the percent. To make a percent, we multiply by 100. 1.3. I'm going to write, well, let me write it first. I'm going to round 1 decimal, please. So the efficiency of the incandescent light bulb is 1.3%. The other light bulb, the LED, the lumens are 250. And the watts is 2.5. And we know 1 watt is 683 lumens. So we get 0.14. Notice it's definitely larger. If we make it a percent by multiplying by 100, we're getting 14.6%. Definitely more efficient than the incandescent light bulb. And that's why they're trying to convert to all LEDs. Not the best light to do homework under, but you're saving. They're a lot more efficient. And they're supposed to last a lot longer. Any questions on that? So you'll have to find both and write a couple sentences. Any questions? But that's definitely on there. Number 22. So this one you need to do it algebraically and graphing. Suppose a person has a retirement investment portfolio that consistently earns 3.7% annually. In retirement, she intends to draw $21,000 each year from this account. Calculate the non-zero equilibrium value of the investment. So what they're doing is, remember, equilibrium is when what you're going in is what's coming out. And she's making 3.7% off of whatever's in there. 3.7% needs to be written as a decimal first. Divide it by 100 or move it to the left 2, but this would be the rate you would use. So this amount, excuse me, of the total that's in there needs to equal what she wants to take out. Because this is what you're making in interest. 3.7% of what's in there needs to equal what's being taken out to be at an equilibrium. So to do it algebraically, you would use this equation. To solve for x, since this is multiplied, we would divide. So you need $567,567.57. Or you could say approximately $570,000. So she needs $570,000 in the account so that she can take 21,000 out every year. Any questions on that? Rounding is fine with me. Just show your answer and then let me know that you're rounding. Or just use the whole answer, round to the nearest penny though when it's money. It's up to you. Any questions on that one? Oh, the graph. Sorry, I forgot about it. When you're going to do the graph, where did I put it? There. You'll have to do both on the test. To do the graph, to make it a little simpler, if you look at this, just set both of them equal to y. Y equals 0.037x. Y equals 2100, and then graph both of them. So once you set up your algebra equation, if you set both sides equal to y and graph it. So you go to desmos.com. Oh. I keep hitting the wrong button. There we go. And then graph both of them. So the one was y equals 0.037x. Hit enter to go to the next one, y equals 2100. Now we can't see, so we want to zoom out until we find it. There we go. Now it's hard to tell exactly where it is. All you have to do is touch one of the graphs. So click on one and it'll show you. Then you click on that and there's your answer. 567.57. You would just take a picture of this and attach it.
Why wouldn't the second Y be 21,000 instead of 2,100?
Oh, I didn't, yep. It should be, I just didn't hit my other zero.
Okay,
Thank you. So since I didn't notice though, when I do that, it should, yeah, it changed it for you. So then you just go back. Come on. I wonder if I did that in the thing too. Did I write it with three? Yeah, I did. There it is. Click on one. There we go. So be careful if you do type something wrong, at least it'll be in the picture, so I'll know you knew how to do it. But it was 3 zeros. And then just take a picture. I want to be able to see both graphs and make sure the point's showing. Any questions? Awesome. 23. A section of exterior wall has an R value of 19 hours, degrees, feet squared, BTUs, and an area of 200 square feet, where the interior temperature is 70 degrees and the exterior is 30. How many BTUs per hour are lost? So when we're talking about our heat loss, and this will be a rate that we're losing it at. It's the change in T, so that means to subtract your temperatures, times your area, divided by your R value. Change in our temperatures, our outside and inside 70 minus 30. It was Fahrenheit. The area, 200 feet squared, divided by our R value, which was 19 hours, degrees Fahrenheit, feet squared per BTU. The feets cancel, the degrees cancel. And you just calculate. It seems a little large. Let me make sure. 40 times 200 divided by 19. Are you getting 421?
I did.
Okay. So you're getting 421 BTUs per hour. That's how much heat is going through the R rating of 19. Any questions on that? So it sounds like that's one they need more insulation. Any questions? And that formula is on that formula sheet. Here. If you want to add that the change in temperature, subtract inside and outside temp, you can. But that delta just means change, so change in temperature. This 1.1, it doesn't matter to me. You can use 1 cubic meter. That's what your book uses. They're just rounding it. So I just had that there in case you looked on the internet. It is 1.1, but so it's a little bit bigger. But we talked about that. Okay, number 24. Water flow. Water flows into a large tank at a constant rate of 10 gallons per minute. There's an outgoing flow rate R related to the height of the water. Because remember, the height of the water will push it down the drain faster the higher it is. So they give us the formula R equals C times H. Draw the stuff. Well, I'm going to write it first. C is a constant, and they gave it 1.25 H. So this is our formula. You just plug into it. But first they want us to draw a stock flow diagram. So we have an inflow of water into our tank. And it's only showing it going out. I believe it's just one spot because they didn't say anything different than that. So this is coming in, whether we're putting it in or from the spigot, and then out. It doesn't need to be fancy. Just if there was more than one way of going out, then make sure you show that. Like if they had the drain and they had evaporation, but they don't in this one. But if they did, then you'd show both. If you can draw a basic one, then when you see the more detailed ones, you should be able to understand it. So that's all I'm looking for. At what height will the water level in the tank be equilibrium? Well, that's when these two are equal. So we just plug in, we're looking for height, we plug in for R. R is the rate, which is 10 gallons per minute. 10 equals 1.25 H. Because we know it's at an equilibrium when what's going in is the same as what's going out. If we divide, then because this is multiplied, you divide by it to get H by itself. And we get 8. So the height is 8 feet. Any questions on that? When the height in the tub is 8 feet, then the water flow is at an equilibrium. Any questions? Remember to answer everything in a complete sentence. The floor of a poorly insulated attic has an R value of 10. The homeowner plans to reduce heat loss through the attic by adding a layer of fiberglass, which has an R value of 20 on top of the existing floor. what will be the overall R value of the new sandwich floor? Consisting of the old one and the new one. Well, if you have an R rating of a batting, and then you add another one on top of it and another one on top of that, you can just add them. Because each one is making another barrier. It's not a fraction of it. You can actually just add them together. So if we had one that was 10 and we put one that's 20 on top of it, then our new R value is 30. So your R value or your R rating is 30. You can just add them together. Any questions? Any questions on anything? We've covered everything. Anything we did not cover in the last 3 days, it's not on there. Any questions? There's no problem. No. Yeah. So there's 10 problems on the test. There's one graph and it's a percent. The graph that's there. For instance, if this was Girl Scout cookies and 62% prefer Thin Mints, although peanut butter sandwiches are better. In my opinion, anyways. But Thin Mints is a favorite for some reason. And maybe they asked 250 children what their favorite Girl Scout cookie was, and 62% said Thin Mints. How many children said Thin Mints? So there's a pie chart, and I'll tell you how many there were, and you need to tell me how many chose whatever that question is. But so 62%, because I was going to take it off. I was going to put it back on. The importance of this problem is, one, remembering that what do we have to do with that percent before we work with it?
Change it to a decimal.
Exactly. 62% divided by 100 is 0.62. Now we want 62% of 250 children. That means to multiply. Of is multiply. So 62% of 250 tells you to take your decimal and multiply it by how many there were. In this survey, I said there was 250. That way I know you understand that you need to multiply them, and I know you understand that you need to make it a decimal and how to get the decimal. So it's a good problem on me making sure you understand those things. And so it would be 155 children chose Thin Mints out of the 250. But it's just a basic, it's a pie chart, and then I'll ask you to find out how many of one of the questions or answers, I mean. So that's what the graph that's on there will look like. Any questions?
The percentage is going to be inside the graph.
Yeah. So
Okay.
maybe 62, 3%. The one with the coconut, I don't like the coconut. Well, my son's allergic to nuts, so. we'll just put other, but 6, 7, 8. Something like that. But yeah, the percents will be there, and then how many took the survey. Any questions on that? So that's the only graph. Because I know a lot of students were worried about the graphs, but I think the graph was the easiest part. But I took you do not have to draw a graph. You just have to be able to read this one. Well, it's not Girl Scout cookies. It's something to do with sustainability. I forget. Any questions? Okay. If you do not have any questions, I will see you on Friday. If you have questions while you're studying, send me a text. Oh, you know what? I might have made it mention last class. I don't remember when. A couple people emailed me and they have a class right after this one. And so I told them I'd open the test at 9 a.m. So if you do want to start it early, anytime between 9 and 10, you can just get on. It'll give you the password. So you'll have, here's one, and I'll show you. It's one from my other class, so the password won't be the same. I don't have it right there.
So the test opens at 9 and closes at 10?
Okay, no. So
Okay.
what'll happen when you get on, it will have something like this, except it's a different password. So then you'll have this password, you'll stay on Zoom, and then you'll go to your course, and where it says exams, it's not showing right now, it will be right here. When you go in, you type in that password. When you type it in, it will give you, I went with an hour and 15 minutes. That way, if your computer's running slow and it's not uploading, you'll have extra time. But it doesn't start it till you start. So if you start at 9, then it's going to go an hour and 15. If you start at 10, it's going to give you an hour and 15. So it all depends on when you start. That's up to you. So you do have, if you can't get on until 10, you get on at 10 and you have your 50 minutes. It should not take longer than 50 minutes, but I like to leave that leeway just in case something happens. But stay on Zoom with your camera on until you've submitted the exam. When you're done, you can take pictures of it with your phone, but you can't use your phone until you are done. I think that's everything, but yeah, you can start it early if you want, but you still only have the hour. Now, if you need more time, I mean, don't go way over because you shouldn't have to. What will happen is might not let you post it. So if you run out of time, it might lock you out. Just email me a picture of it. But I don't think that's going to happen, especially with this exam, I don't think. But things happen. If you get kicked off, get back on immediately. If your camera doesn't work on your computer, use your phone. But I have to be able to see you. And most of you use your names, which is nice. If you have a nickname or you're using someone else's computer, for the test, change it to your name. You just have to click, I think it's right here, and then it will let you change a name. Any questions? Okay, if you do not have any questions, I will see you Friday.